Let me introduce myself. I used to work at Google, then ran my startup FutureCam for a few years. Then worked as CTO of a startup. I now work as a consulting CTO with multiple companies. Today we are going to talk about how to use static typing effectively. And as the name says, this is not relevant for engineers who use dynamically typed languages. Let's discuss the use of optional types to begin with. I use Swift as an example, but the principles apply to many languages. Some of them may apply in a different form, a few of them may not apply at all, but by and large, they'll apply. In modern statically typed languages like Swift, a variable can be optional, which means it's nullable. So if you take, for example, Java, and you said cart, this can be null, right? Java doesn't have the concept of nullable and not. They're just annotations, but they're not enforced by the compiler. Some statically typed languages designed afterwards enforce this. So in Swift, for example, you can have a variable like this, or like this. This is non-optional. It can never be null or nil as Swift calls it. These two can be nil. So you can call a function cart.placeOrder on it like this. This one you'll have to say use this syntax. So this says if cart is not null, place an order, otherwise if it is null, do nothing. Here you can use this syntax. This is called an implicitly unwrapped optional. What this does is if it is null, it crashes at runtime. And if you don't want that, you have to add a null check yourself. So when you use this syntax, you're telling the compiler to get out of the way. Now, how do you use these three? Obviously, variables that logically cannot be null should be of this type. For example, let's look at line 193 here. This is a focus mode. And a camera has different focus modes like manual focus, autofocus, continuous autofocus, etc. But it has to be in one or the other modes. So that is why this is not optional. If I were to make this optional, either this way or this way, I'm saying that the camera might not have a focus mode at all, which logically doesn't make sense. So this is when you make it non-optional. The second case is when something legitimately can be null. Here, for example, this represents the ultra-wide camera, but it can be null because some phones don't have an ultra-wide camera. The third case is when something can be null only in an edge case. So if you look at line 15, for example, all phones have a wide-angle camera, right? That's the default one. It's been there for like 10 years or whatever, right? So this syntax tells the compiler to get out of the way. You can use it as if it's not null. So this is an escape hatch from the type system, right? You're telling the type system that you'll take care of it yourself. Now, when can this be null? One case is when an iPhone's wide-angle camera is broken. And I don't really care whether the app works or not on those phones. Those are like 1 in 1,000. It's not worth making the code cluttered. For example, if I use this camera in 100 places, if I don't make it implicitly unwrapped, if I make it this every single time, I have to call camera.wide with a question mark. So we don't want that. So this is the difference between a purist and a practical person. If you look at it from a pure type systems point of view, and unfortunately there are too many people in the Swift community who hold that point of view. They would say you should make this this. Moving on. The other case when this can be null is if restrictions are on, such as parental controls. But I handle this in the beginning of the app startup before we handle the camera hardware. And again, you want to check it once instead of having to worry about it every single time. So that is why I made this implicitly unwrapped optional. So the type system is an aid to you. It is not your boss. Use it when it helps. Feel free to bypass it when it doesn't help. So anyway, these are the three types of variables. Here itself, you can see this is not optional at all. This is optional. This is an implicitly unwrapped optional. Now let's discuss casting. In all statically typed languages, you have to have casts. Again, Swift purists. Okay, so again, there are three types of casts. Suppose you have A as type B. You have a variable A of type A and assume it's not optional, equal to whatever the value is, right? And you want to say you have a variable B. Now you want to assign it this way. This is a cast that is guaranteed to succeed. Moving on. Swift convention recommends using this kind of cast, which can fail at runtime and return null. The third kind is this. Here you are saying if it is null, if it is not an instance of type B, crash the program. And again, Swift purists would say you should never use this. Never is always too strong a word. So for example, if you look at this, there's only one instance of this protocol or interface if you're from Java, and that is main controller. So there's no way this can fail. So again, use your common sense, right? The problem with too many checks is if you make this optional, now you have to worry about error handling. For example, guard let else. Now you have to figure out what to do here. And if you have a function that invokes a callback and you return prematurely this way, then the function is violating its contract by never invoking the callback in this case. So which creates a second problem, right? So, and it also breaks up the flow of execution. It's hard to read with so many branches what's going on. And you also get confused which are these code paths that are actually taken and which are not. So don't overdo static typing. Remember, it's there for you, not the other way around. Use it to the extent it helps. Moving on. Use an enum when something can have only one of a predefined set of values. So FutureCam has hints which appear as you use the app. These are suggestions to use the app better. And these are the only suggestions possible. Even though these are strings, right? We don't use a string. So for example, if you see where it is used, oh well, I guess nowhere. Yeah, but suppose it were used here. You want to do it this way. Even though it's a string ultimately, you don't want to do this because people can put in any string. And then will you show a message to the user saying hello world? Right? You don't want that. Or the function will have to check for validity, creating a runtime error. And the whole principle of static typing is to catch these at compile time. And again, some people disagree with that premise fundamentally. If you are in that camp, you should not be using a statically typed language in the first place. But when you use a statically typed language, don't fight the language. That's the worst of both worlds. Writing dynamically typed code in a statically typed language is the worst thing you can do. Either use a dynamically typed language or use a statically typed language the way it is meant to be used. Moving on. When you are using generic types, specify the types. Don't keep it any or object in Java. For example, this is an array that consists of tuples, and each tuple has two elements, a blend kernel and a string. We didn't say any because now someone can put a number or a button or anything into it or a username. So don't do that. So in Java, for example, you don't want to say list equal to something, you want to say list of person. Sometimes we can't specify the type fully. Here, the keys in this dictionary or map, if you are from Java, are strings. The values can be any. Actually, they can't be absolutely any. They have to be one of a set of values, maybe integers, floats, bools, strings, etc. Because these will be given to some API, and that API won't know what to do with a button, for example. So this is a situation in which static typing cannot represent the logical constraints you have. Again, don't hesitate to use this. People say this is a bad sign. It's not. It's bad when used indiscriminately, but it exists for a reason, which is that no static type system is perfect, handles all the cases. So use any. But here, since you can specify the type, since it logically must be a string, make it a string. Moving on, avoid null when you can use empty. For example, this function to show a hint takes a string. And if you pass the empty string, it removes the hint. So there's no separate remove function. There's only a show hint function. Now, let's write some documentation. To remove the hint, call show hint. Now, someone may say, hey, let's not do this. Let's make it optional. I think this is a bad idea because now the implementation of this function will have to handle both the cases, null and empty. And I've seen bugs caused by using one instead of the other. And if both are going to be handled the same way by this function, why do you want two in the first place, right? So the whole point of static typing is to constrain constrain the range of acceptable values at runtime. If null is not an acceptable value, don't permit it because then you are creating yourself a problem of how do I handle it. This goes for collections as well, like an array. If you have an empty array, don't use null. So for example, this struct contains an array and it's initialized to an empty array rather than null, right? The type is not nullable. So that way, whenever you use it, you don't have to check. Otherwise, you would have to check here, 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 and here. Oh, and here, probably 7, 8 times, which just clutters up the code. And when the code is cluttered and hard to understand and has redundant checks, it increases the number of bugs. So don't do that. Similarly, instead of an optional double, see if you can use an invalid value like -1. So if you look at this variable, this is the gap between two events happening. Forget what those events are, but this is a time interval. It can't be negative, right? You can't say minus 3 seconds have elapsed between the two events, such as two photos being taken. So here negative values which are invalid are used as a marker instead of null. Moving on, use unsigned for variables that can't be negative. You can't capture a negative number of photos, for example. Why is that important? Otherwise, you'll have to handle it. Imagine a shopping cart. If you have an add items function that takes an item and a count and adds those many items of this item, like 3 pencils or whatever it may be, right, to the shopping cart in an e-commerce store. Now, what is wrong with this? What if I call cart.add_items, whatever, pencil, and -2 pencils? This will create a situation where, so let's write some documentation. The item count, let's say, and order value increase. We won't define the order value, but this is what the contract of this function is. Now you can end up with a situation where the contract is violated because the item count can decrease. If I had 5 items in the cart and I've added -2 pencils, now I have 3 items in the cart. Or worse, it can even become negative if I create an empty shopping cart and add -2. So then whoever is using it will have to handle a negative item count. So you can see that complexity and errors percolate from one place in the system to another. And this happens in dynamically typed languages. In statically typed languages, the philosophy is to prevent these errors from propagating by catching them as early as possible. So why should this be negative? It shouldn't make this. Then you don't even have to write code of the form if count less than 0. Now what do? Do you return null? Do you return false, but this doesn't have a false? Any kind of return type. Do you throw an exception? Do you ignore it? All these questions and complexity comes up. When you make it uint, you don't have to worry about this stuff. Sometimes, though, it just causes unnecessary casts. So in that case, you can just leave it, but otherwise. Moving on. When you have Typedef data types, use whatever the API you're working with uses. So let's take an example. Here, this gives you a raw format, which is an OS type. And what do we do with this? We pass it to this initializer or constructor if you are from Java or other languages. What does this constructor take? It takes in an OS type. So now we can verify that the data type matches. This returns an OS type and this takes in an OS type. What is an OS type? It's a typedef for 4-char code. And what on earth is a 4-char code? It's an unsigned date. So we could have made it this way. Uint, unsigned int, uint, whatever the syntax is. It will work. It won't create any warnings or errors. It won't fail at runtime. Still a bad idea because it imposes cognitive load on the person reading the code to try to understand what this is and does it fit what is needed. And you want to reduce cognitive load. Programming is complex enough, right? Don't make it more complex. And with a typedef, the other advantage is that they can theoretically change what it is typedef to, and your code won't have to change. In this case, for example, if they decide to make it an unsigned int or whatever it may be. Moving on. Define your own type defs for complex data like this. So this frame blender, it has two callbacks. Once it's completed, it has a completed callback. And whenever there's a partial result which is generated incrementally throughout the process, it invokes this callback. So this is cleaner than this mess here. And when you look at it this way, it is also more readable. And it puts the focus on the logical purpose of the callback rather than the implementation details, like does it take two arguments or three, and what is the data type of the third. All those details are de-emphasized. You want to emphasize the logical purpose. Anyway, this is how I use static typing effectively. If you have any suggestions, thoughts, feel free to leave comments. Let's learn from each other. And if you'd like me to work with your team improving its code quality, there's a link in the description. Thank you.